we are going to discuss about the Dakin reaction. So we are going to discuss about the what is Dakin reaction, what is the principle behind that Dakin reaction, and what are the applications of this Dakin reaction. Let us see the video on this Dakin reaction. That is, what is this Dakin reaction? So it is the replacement of aldehyde group of ortho and para-hydroxy or ortho-aminobenzaldehyde or a ketone by a hydroxyl group on reaction with alkaline hydrogen peroxide. So this is the definition for this Dakin reaction. Actually, that aldehyde group or amino group that will be replaced by a hydroxyl group. This reaction will be carried out in presence of hydrogen peroxide and sodium hydroxide. So here you will find one example, that is salicylaldehyde. So benzene contains a hydroxyl group and an aldehyde group. So this in presence of hydrogen peroxide and sodium hydroxide, it will be converted. This aldehyde group will be converted into hydroxyl group with the elimination of formic acid. So catechol ring will be formed with the elimination of formic acid. What is the mechanism behind this one? So as we already mentioned that one, this reaction will be carried down in presence of hydrogen peroxide and sodium hydroxide. So sodium hydroxide, it will be divided into anion and cation, that is Na plus and OH minus. Similarly hydrogen peroxide, that is H₂O₂, OH. So in presence of this base, it will be converted as OH₂O minus, that is one hydrogen will be added here, that will be eliminated as a water molecule. So we are taking the sodium hydroxide and the hydrogen peroxide, so that will be converted as Na plus and OH minus. Similarly hydrogen peroxide, it will be converted as OH₂O minus. Okay, that is an anion. So here we are going to add this anion, that is OH₂O minus will be added to the substance salicylaldehyde. So benzene is there, hydroxyl group is there, so it will be attached in second position, aldehyde group is present, CHO is present, so it will be added, this OOH will be added to this aldehyde, so it will be attached to, it is containing double bond, C double bond O. So this OOH will be added to this one, so it will be converted to this compound, that is CHO minus OOH will be present in that. So already we have mentioned that one, that sodium hydroxide will be converted, that is anion as well as cation, that is Na plus and OH minus. It will be added here, that sodium will be added here. What will happen? That sodium will take the hydroxyl group, that will be eliminated as sodium hydroxide. So what is remaining? Hydroxyl group is eliminated as sodium hydroxide, so it will be converted into OCH2. So it will be converted as OCHO. Now we are adding with the water molecule, that HOH will be added here. What will happen? So here it will be added, that HOH CHO, it is eliminated as water molecules. One hydrogen will be added here, so catechol will be formed. So the aldehyde group that is replaced by the hydroxyl group, that is catechol will be formed with the elimination of formic acid. So salicylaldehyde in presence of sodium hydroxide and hydrogen peroxide, it will be converted into catechol with the elimination of formic acid. So this is the mechanism behind the Dakin reaction. So what is the application? What are the applications of this Dakin reaction? First one, it is useful for the synthesis of pyrogallar monomethyl ether. So what is this pyrogallar monomethyl ether? It is used as an anesthetic agent. The second one is synthesis of hydroquinone. So it is useful for the synthesis of hydroquinone, that is to the benzene ring, first position and the fourth position, hydroxyl group is present, means it is hydroquinone, and it is also useful for the preparation of phenol. So these are the applications, that is useful for the synthesis of pyrogallar monomethyl ether that is used as an anesthetic agent, and synthesis of hydroquinone. This hydroquinone is useful for the treatment of acne, and it is also useful for the preparation of phenol. Okay, usually the aldehyde groups or ketone groups that will be replaced by the hydroxide. We will see one example, that is 2-hydroxy 3,3-methoxy benzaldehyde. Okay, so in third position methoxy group is present, and second position hydroxy group is present. So it is benzaldehyde. In presence of hydrogen peroxide, sodium hydroxide and water, what will happen? That aldehyde group will be converted into hydroxy group. So this is the example we have seen. This used as a anesthetic agent. This is the pyrogala, alkaline pyrogala, that is used as an anesthetic agent. Next one is para-hydroxy acetophenone. Acetophenone means C6H5COCH3. In fourth position or para position, hydroxy group is present. This in presence of hydrogen peroxide, sodium hydroxide and water. It will be converted into that COCH3. Acetyl group will be replaced by the hydroxy group. So acetophenone in presence of sodium hydroxide and hydrogen peroxide as well as water, it will be converted into hydroquinone. I hope you could understand the Dakin reaction. Thank you.